Hello everyone. So welcome, and today here we're going to try to investigate formulas for the sine of a plus b and the cosine of a plus b as well. Now you may ask yourself, like, you may like wonder what does sine of a plus b means. Like, let's say suppose we have our a to be, let's say, 30 degrees, and our b to be, say, 60 degrees. Then what does sine of a plus b, which is sine of 30 plus sine of 60, no, sorry, sine of 30 plus 60 degrees, do we say this is equals to the sine of 30 degrees plus the sine of 60 degrees? This is something that naturally you may think is equal, but let's investigate it and see. Here, over here on the left, you have your sine 90, because 30 plus 60 is 90, so this is sine 90 degrees. While over here to the right, you have sine 30 is half, and this is square root 3 over 2. But we know that sine 90 degrees equals to 1. So here 1 does not equal half plus square root 3 over 2. And for this reason, we are going to discard the idea that probably sine of a plus b, which you may think is equals to the sine of a plus the sine of b. So they are not equal. Now, that means we have to investigate a formula for the sine of a plus b and the cosine of a plus b as well. Now, when you here, let's assume that this AOB is a full angle, but let's say this line OK traces the point A and B here. The angles is, so the line OK here separates this into two angles, A and B. And now for this line OC, let's just pick any arbitrary point here. Let's say this is point, let's call it point P. And from this point P over here, let's draw perpendiculars to this line OA and this line OK as well. So a perpendicular to line OK will go this way. So we assume this is to be an angle 90 degree, and then a perpendicular down here. Okay, let's assume this is 90 degree as well. And also we're going to obviously draw perpendicular from here down to here. And let's label some points. So here this is M, let's call here M, and let's call here N. Let's call here our Q. And from here we draw perpendicular as well. And then let's get here as our R. So we have our points labeled out right here. Next, we're going to look for this angle over here. Notice that this angle is going to be our angle. This angle over here is going to be our angle R, QPR, and the angle QPR. Notice that this is going to equal a 90 degree minus angle PQR. The reason being that since here is 90, this sum of these two angles here should equal to 90 degrees. So here we are going to have this is equal to 90 degrees minus angle PQR, angle PQR. Now this here, notice that since this is a perpendicular here and this is also perpendicular, that means this line here should be parallel to this line OA. And if that is the case, then means this angle over here and this angle over here, they should be alternating angles, and we know that alternating angles are equal. So that leaves us that this angle which is 90 degree minus PQR is equal to this angle over here. So this is equals to angle, let's call here K, let's call here our T, angle RQT, angle RQT, and this is equals to angle A. So this is equals to angle A. So we can comfortably write this as our angle A. And that is probably all that we need to look at here. Now, we've already proven that if we take any point on this line OC and draw perpendicular here and perpendicular to this line, then if we take a perpendicular from this point to this line here, this angle we get, this triangle, this angle is going to be the same thing as our angle A. Now, let's say sine A. Let's look at sine. What would it be the sine of A plus B? Sine of A plus B will be equals to OP over, say, OM. So that will be equals to OP over OM. Now, OP No, not OP over OM. It is going to be equals to PM. So rather, because sine of A plus B is supposed to be the opposite over the hypotenuse, so it's supposed to be PM. So you're supposed to have a PM. So you have supposed to have a PM over OP. So this was equal. Now your PM is your PR plus your RM. So this is going to be your PR plus your RM, all divided by OP. Okay. Now we can split these two expressions over here, and we have your PR over OP plus your RM over OP. Okay. Now PR, now RM rather is same thing as QN. So this is going to be your PR over OP plus your QN over OP. Now this RN PR over OP, we're going to connect it, since PR here is adjacent, we're going to connect it with some hypotenuse there. So that means we're going to do PR over PQ. So we're going to do PR over PQ. And since we already added PQ here, we're going to cancel some PQ as well. So then we bring down our OP. And the motivation behind this is because we have a PR here, but it's in terms of this angle, it's an adjacent. So we can connect it with the hypotenuse and something good will happen. So plus, now QN is like the opposite. So we can connect this QN with OQ as well. So you have QN over OQ. Now we're going to cancel out the OQ over OP. So this would become PR over PQ, or PR over PQ is equal to the adjacent of a hypotenuse, which is equal to cosine A. So this we call cosine of A times PQ over OP. So PQ over OP would equal the opposite of this, and the opposite of a hypotenuse. So that would equal sine B. So that we call sine B plus QN over OQ. QN over OQ will be opposite over hypotenuse, which is equal to sine A. So you have your sine A. And then OQ over OP. So you have an OQ over OP. So that will be like adjacent over hypotenuse. That is going to be cos B. Cos B. So you have this is equals to sine of A plus B. So we have found formula for sine of A plus B. So that sine of A plus B is cosine A sine B plus sine A cosine B. Similarly, we can actually get formula for cosine of A plus B as well. So we come, let's take this down. Okay, so let's see how we can get formulas for cosine of A plus B. So cosine of A plus B, this would equal, cosine is equal to adjacent over hypotenuse. So where's the adjacent? That would be OM. OM is adjacent, hypotenuse is OP. So that would be OM over OP. Now OM is equals to ON minus MN. So that is ON minus MN all divided by OP. And this will be equal to, now MN is something as QR, because we badly need to connect this to QR, because this is where we have a triangle. This triangle that we are considering, this one won't help us that much. So we have an ON minus MN, which is QR, minus QR all over OP. And we can put this as ON over OP minus QR over OP. So we can come to the other part of the board now. So we have an ON over OP minus QR over OP as well. Now, ON connects with what? We have an ON. Okay, it connects, this is an adjacent, so you connect with OQ. So I'm going to connect with OQ. So we have an ON over OQ times OQ over OP minus what does QR connect with? QR connects with PQ. So we're going to try to connect it to PQ. So that is a QR over PQ times PQ over OP as well. So that would be equal to ON over OQ would be what? ON over OQ would be adjacent, and the hypotenuse is that is cosine A. So you have a cosine A. What is OQ over OP? OQ over OP is still the adjacent of angle B. So you have a cosine B. Now, what is QR over PQ? QR over PQ, that would be like QR, that would be the adjacent of this angle right here. But we know this angle is 90 degree minus this angle. So instead of having cosine of 90 degree minus angle A, we can have sine of 90 degree minus A. So we have sine, so this will be sine A. This will be minus sine A. And then what will be PQ over OP? PQ over OP. So that would be the opposite of this angle B, which is sine. So this will be sine B. So we've gotten two incredible formula, and number one is that the sine of A plus B. Hold on, let me check this out. We've gotten two useful formulas here, and which is that sine of A plus B is sine A cosine B minus cos B, or we can see rather write sine B cosine of A, and then also cosine of A minus B is equals to cos A cos B minus sine A sine of B. So these two formulas are the addition subtraction formulas for sine and cosine. This is plus. Then we can always get the formula for sine of A minus B, and also cosine of A minus B, and that's what we're going to do in the next video. So thank you for joining in, and please do subscribe to the channel. Bye and have a nice day.